Good morning all. Today we are going to study about construction of DC generator. This is a very important topic as far as university exams are concerned. Basic working principle along with the construction of DC generator has been asked twice in the previous year university question papers. Theoretically, the construction of DC generator is same as that of the construction of DC motor. So in general we can say that we are going to study about the construction of a DC machine. Students are having a pre-assumption that DC machine is a term which is being used only for DC motor, but it's not like that. DC machine is the term which is commonly used for both DC generators as well as DC motors. Let's look into the various parts of a DC machine. The major parts are yoke, pole, field winding, armature core, armature conductors, commutator and brushes. In construction, you are going to study in detail about each part, what each part is actually made up of and what purpose does it serve. We will start with yoke. Yokes are generally made up of cast iron or steel. The main purpose of yoke is to provide a protective cover for the internal sophisticated components which are being present inside the machine from external entities such as moisture, dust, mechanical shock, etc. Yoke serves the purpose of providing a continuous path for the magnetic flux. If you are considering this as north pole, then definitely the adjacent one will be south pole. As you are aware, magnetic flux lines will start from north pole and they will move towards the south pole, and they will complete their path through this yoke. You will be able to see the flow of magnetic flux along the cursor direction. It will be starting from this north pole through this air gap and armature. It will be coming to the south pole and they will complete their path through this yoke. Hence, yoke serves the purpose of providing a continuous path for the magnetic flux. It is the yoke where the poles are being placed or screwed. So we can also say that yoke does the function of providing mechanical support for the poles also. Next part is pole. Pole is actually a pole core and pole shoe assembly. This portion is the pole core and this is the pole shoe. The purpose of this pole core is to carry the field winding, and the purpose of the pole shoe is to spread out the magnetic flux through the air. The pole shoe also serves the purpose of providing a mechanical support for the field winding which is being placed over the pole core. This pole core and pole shoe assembly can have either a solid structure or laminated structure. In modern structures or in modern design, laminated structures are generally preferred. In laminated structure, this assembly, this whole assembly, that is pole core and pole shoe assembly, is made up of several thin laminations. You will be able to see here several thin laminations of annealed steel which are stamped together using the hydraulic pressure and riveted using pins through this rivet holes. That is, numerous sheet-like structures will be pressed together using the hydraulic pressure and they are joined by using the pins through these holes. So this is how the construction or the pole core and pole shoe assembly is being made. Another important point which I wish to mention here is, if you are looking here, the pole shoe construction, in the pole shoe construction you will be able to see the cross-sectional area of pole shoe is very large comparing with that of the pole core. Since the pole shoes are provided with a large cross-sectional area, the reluctance value will be very small. You have already studied the expression for reluctance in your first year, that is S is equal to L by nu A. Reluctance is inversely proportional to the cross-sectional area. So if the cross-sectional area is large, means the reluctance will be very small. If the magnitude of reluctance is very small, Then from the standard relation of flux, that is flux is equal to mmf by reluctance, you will be able to understand for small value of reluctance, the magnitude of flux will be very large. That is, ineffectively, by providing a large cross-sectional area for the pole shoe, you will be able to spread out a large value of magnetic flux through the air gap. That is the purpose of providing pole shoe with a large cross-sectional area. Next, we are going to study about field winding. Field winding is also known as pole coil. Pole coils are generally made up of copper or aluminium, preferably copper, due to their better ductility behavior. That is, you can easily fold or twist the copper wire without causing severe damage to it, comparing with that of the aluminium. Field windings are former wound. That is, we will be using a frame to wound the field winding. Thereafter, this frame will be removed and the field winding will be placed over the pole core, which is being supported by the pole shoe. Whenever current passes, DC current passes through this field coil, both this pole core and pole shoe assembly together will act as an electromagnet. If you see in this diagram, the terminal box consists of 4 terminals, 2 input terminals and 2 output terminals. All the field coils are connected in series. It can be clearly seen here. See, it will start from here, and this is field coil number 1, and the field coil number 2 and 1 are series connected. 2 is in series connection with 3 and 3 is in series connection with 4, and the final terminal is coming to the terminal box. So 2 terminals in the terminal box are meant for field winding. Even though the field coils are series connected, the connection is made in such a way that alternate field coils will be carrying current in opposite direction, so as to ensure that adjacent poles are of that of opposite polarity. Next, we are going to study about armature core and armature conductors. So far, we have studied about yoke, pole core and pole shoe assembly, and field winding. All this were related with the stator side of the DC machine. Now we are going to study about the components which are present at the rotor side of the DC machine. The main function of armature core is to house the armature conductors. It is these armature conductors which are cutting the magnetic flux lines from the poles to produce the required EMF. This is the construction of armature core. Armature core is cylindrical in shape. It is having a laminated structure, that is, it is made up of numerous circular sheet laminations. These laminations are put together using hydraulic pressure, and then they are reverted using the pins. This construction which we have already set for the construction of pole core and pole shoe assembly. This laminated structure helps to reduce the eddy current losses. You can see it very clearly here. Slots, many slots are being made at the outer periphery of the armature. It is in this slots where the armature conductors are being accommodated. So when this armature core is rotating, this armature conductors will be cutting the flux lines and EMF gets induced in them. If you are looking here, a slot is provided at the center of the armature. This is to fix the armature shaft, and numerous air holes are also provided for ventilation purposes. Armature winding is also former wound just like the field winding. That is, it is wound over a frame and then placed over this slot. In this diagram, you will be able to see the armature winding clearly. All these armature conductors are provided with enamel coating. The function of enamel coating is to provide interturn insulation. That is, in order to avoid the short circuit between this inter turns, enamel coating is being provided. Whenever these conductors are being placed on the slots, there must be also provided with some insulation. Usually paper insulation is being provided at the slots to insulate the conductors from the armature core. So these are the main points which you must know about armature core and armature conductors. The next part you are going to study about is the commutator. The purpose of commutator is same as that of the split rings which you have studied in the working principle of a DC generator. The commutator is made up of numerous segments, as you can see in this diagram, and each segment is being separated by using mica insulation. The purpose of this commutator is to collect the AC current from the armature winding and convert it into a DC one. So it is also known as mechanical rectifier. It is generally made up of hard drawn copper. The factor determining the number of commutator segments is the number of armature coils which is being present in the armature winding. The last part is brushes. The commutator which we have studied before is mechanically coupled with the armature shaft. So whenever this armature rotates, the commutator also rotates along with it. So it's not possible to connect a wire to the commutator for tapping the current from the DC generator to the load, as commutator is a rotating part. So in order to collect the current, the DC current from the commutator, the brushes are being used. The brushes are placed in a brush holder, as you can see in this diagram, and they are made to bear down on the commutator by using a spring assembly here. This arrangement is being made because only if continuous contact is there between the commutator and brushes, then only the current can be properly tapped out from this commutator to the brushes. From there we can get the DC current which is required for the load. With this, we have completed the basic construction of DC generator. Next we are going to study about armature winding. Armature winding is the place where actual energy conversion is taking place. In the case of generator, the energy conversion is from mechanical energy to electrical energy, whereas in the case of motor, the energy conversion is from electrical energy to mechanical energy. In order to get a clear understanding of various types of armature winding and all, you must be familiarized with certain terms. We will look into those terms in detail. If you look into this diagram, the first image indicates a turn, the second one indicates a coil, and the third one indicates a winding. So a turn is formed by two conductors which are being connected by using the end connectors. A coil is formed by several turns connected in series. If you look into this diagram, this coil is formed by three turns which are being connected in series. A winding is formed by series connection of numerous coils, as shown in this diagram. This turn can be also indicated as a single turn coil. Next, you must know the definition of pole pitch and coil pitch. Coil pitch is also said to be coil span. Pole pitch is defined as the center to center distance between two adjacent poles measured in terms of armature slots. If you see in this diagram, the center to center distance between this north pole and the adjacent south pole is 4 slots. This diagram is actually the stretched version of this one. Next, you must know what do you mean by a coil span. Coil span is defined as the distance between two sides of a coil measured in terms of armature slots. If you see here, in this case, this is a coil, and the distance between this coil side and this coil side, or both the conductors of a coil measured in terms of armature slot. In this case, the coil span is also 4. Consider a machine having 36 slots and 4 poles, then you can easily calculate the value of pole pitch by dividing 36 by 4, that is 9. Similarly, if the first coil side of a coil is being connected to the next coil side, which is being placed at the 10th slot, the first coil side is placed at the first slot and the next coil side is being placed at the 10th slot. Both first and second coil sides are the coil sides of a coil or the conductors of a coil. Then the coil span is 10 minus 1, that is 9. So this is how you can calculate the pole pitch as well as coil pitch. Based on the values of coil span and pole pitch, you can classify the armature winding into a fully pitched one or short pitched one. If the coil span is same as that of pole pitch, then you can say it as a fully pitched one. Whereas if the coil span is less than pole pitch, then you can call it as short pitched one. It is also called as fractional pitched winding. Based on the methods of connection, armature winding is broadly classified into two: lap winding and wave winding. The distinguishing features between lap winding and wave winding is very important. In this slide, the diagrams of lap winding and wave windings are shown. You must learn to draw these diagrams. Before understanding the difference between lap winding and wave winding, you must be thorough with some more terms, that is front pitch, back pitch, resultant pitch and commutator pitch. If you see in this diagram, front pitch is indicated as YF, back pitch is indicated as YB, a resultant pitch is indicated as YR and commutator pitch is indicated as YC. The front pitch is defined as the distance between second conductor of first coil and the first conductor of the next coil, measured in terms of armature slots connected through the front end. Back pitch. Back pitch is defined as the distance between two conductors of a coil which are being connected through their back side, measured in terms of armature slots. Next is resultant pitch. Resultant pitch is defined as the distance between first conductors of adjacent coils measured in terms of armature slots. And the last one is commutator pitch. It is defined as the distance in terms of commutator segments measured between two ends of a coil. Now let's see the definition of lap winding. In lap winding, if you are looking into this diagram, you will be able to see the succeeding coils overlaps each other. See, if you are looking here, this is the first coil and this is the second coil. They both overlap each other. And another important point which you must know is, in lap winding, the two conductors of a coil are connected to the adjacent commutator segments. See, if you are looking here, this is the first coil side and this is the second coil side of the first coil. Both are connected to the adjacent commutator segments. As it is lapping back, this is said to be a lap winding. In wave winding, the connection forms the shape of a wave. This is actually a series winding because all the coils over here are connected in series. So whenever the distinguishing features between lap winding and wave winding is being asked, the first distinguishing feature will be the diagram itself. You have to draw this lap winding diagram and wave winding diagram. The second distinguishing feature will be the definition of lap winding and wave winding. Third distinguishing feature, you can identify from this diagram the relation between the resultant pitch, back pitch and front pitch. In the case of wave winding, the relation is resultant pitch is the sum of back pitch and front pitch. Whereas in the case of lap winding, the relation for resultant pitch is the difference between back pitch and front pitch. This is actually the resultant pitch. R is not represented here. So this is actually YR, and this YR is the difference between YB and YF. Lap winding is also known as parallel winding, whereas wave winding is known as series winding. In the case of lap winding, the number of parallel paths will be same as that of number of poles, whereas in the case of wave winding, the number of parallel paths are always 2. That is also a major distinguishing feature. Another important distinguishing feature is lap windings are generally used for low voltage and high current applications, whereas wave windings are used for high voltage and low current applications. So you must know a minimum of 4 distinguishing features between lap winding and wave winding. This is a very important topic. So with that, we are completing today's session of construction of DC generator. You all must learn to draw the construction diagram of DC generator and lap winding and wave winding diagrams. Thank you, and wishing you all a happy Onam. Stay safe.